This is Meluleki from Ukzn. I'm going to present how I teach it on how am I going to teach Euclidean geometry in grade 12. Okay, first of all, our main resource, we're going to use Geometer's Sketchpad in this lesson. I'm going to use Geometer's Sketchpad to convince learners based on the theorem that I'm going to prove. Therefore, my main resource here it is a Geometer's Sketchpad. Okay, first of all, we have a theorem that say if two triangles share the same base and they are between parallel lines, they have equal areas, as you can see our diagram there, and we have our triangle A B C and another triangle we have B D C. Then we have our two triangles and they are between between two parallel lines, and there is a theorem that says they have equal area. Why do they have equal area? Because they are sharing the very same height, so they are sharing very same base, of which is BC, and they have what is common in these triangles? H. Because if we can look that H, the red one, if I can move it along these two parallel lines, we see the distance that is changed. They are equal. It means these two triangles ABC and BCD, they have the same height. That's why they have equal area. They have equal height and they share the same base, of which is BC. And look at our scenario 2 here now. Remember, here in B, they are sharing the very same base, of which is BC. Then they have equal area. Even here now, we have triangles now, FEG, and triangle FEH. They are between the parallel lines, but now they don't have equal area because they are not sharing the same base. But what is the same here? It is the height. Height for triangle FEG and triangle FEH, it is equal because they are between the parallel line. H is the same throughout this line. This is the first theorem that I'm going to use when I'm proving the theorem for today. And I'm going to use this sketchpad to convince learners so that I can able to prove the theorem that I'm going to prove using the understanding obtained from this theorem. If we have two triangles that share the same base and they are between parallel lines, it means they have equal area. And what else? They share the same base, of which is BC, and height. And height doesn't change because they are between this parallel line. And I'm going to use that information to prove the theorem for today. Okay, my lesson will go like this one. Yep, here is my lesson plan. And lesson topic, which is ratio and proportion. And grade, it is grade 12. And duration is 1 hour. I'm assuming that my lesson will take 1 hour when I'm teaching grade 12, the theorem for ratio and proportion. Okay, lesson outcome or expectations. At the end of the lesson, learners should be able to do the following. First, prove the theorem on ratio and proportion. And what is that theorem? The theorem that say if the line drawn parallel to one side of a triangle, then it divides the other two sides in proportion. This is the theorem that I'm going to prove today. And lesson outcome number 2. At the end of the lesson, learners should be able to apply the theorem in problem solving. That is the lesson outcome for this lesson. Okay, teaching resources. What am I going to use to teach? I'm going to use Sketchpad to teach this theorem. Then teaching method, I'm going to use problem solving and question based. Then prior knowledge of these learners, or what I'm assuming that what I'm assuming the knowledge learners already have. Then first of all, I'm assuming that the learners know the formula for calculating the area of a triangle if we're given the height. Then what I'm assuming, number 2, I'm assuming that the theorem, the learners understand the theorem. Let's say if triangles of a parallelogram are on the same base or base of equal length and between the same parallel lines, then triangles have equal areas. And I have proven that, and I've shown that using the sketch pad, that if we have two triangles and they share the same base and they are between parallel lines, then they have equal areas. I'm assuming that learners know that theorem for today's lesson. Okay, my introduction. How am I going to introduce my lesson? Okay, I will ask learners to give me formula to calculate the area of a triangle if we are given a perpendicular height, or if we can calculate it. I will ask the learners to give me that formula, and I'm expecting learners to give me the formula that say half base times height. And why am I restricting them? Because I'm restricting them. I say if we are given the height, or if we can calculate it. Why am I restricting them? I restricting them because sometimes they might give me the formula from area rule that works only if we are not given a height, and I don't need that formula at the moment, because I need the formula that say half base times height, and I'm expecting them to give me the formula that say area of a triangle is equals to half base times height. I'm expecting them to give me that formula as my introduction, as I'm asking them to give me that formula. In number 2, what am I going to do in my introduction? I will ask learners the properties of a triangle that are on the same base or bases of equal length and they are between the parallel line. And I have shown that using that sketch pad, that if we have two triangles that are between the parallel line and they share the same base, it means they have equal areas. I will ask learners that property, and they will say the area, they have same areas of triangles. As a recap, I will then use sketchpad to convince them that two triangles have equal areas, as I have shown using the sketchpad before we introduce my lesson. As I have shown how to use that sketchpad to convince the learners that two triangles that are between parallel lines and share the same base, they have equal areas, as I've shown that as my introduction. Okay, then I'll move on with my lesson development. Then in my development, as I'm going to teach this lesson, as a teacher, I will break down the proof by asking learners what they already know to lead them to the generalization of a proof. Because that is the most important thing when you are teaching the learners proof. You have to give them the guides on how are you going to prove that lesson so that they can understand. You have to break it down, that proof, as we are going to teach that lesson. Okay, here the given the information. That's why if we're given triangle A, B, C, and they say D lie on AB and E lie on AC, and then DE is parallel to BC. What is required to prove that AD divided by BD equal to AE divided by EC? Okay, from this given information, then I will ask learners to draw any triangle with the given information. They can draw any triangle, and they can draw triangles like this one, because I will ask them to draw any triangle that they like, but that it must have that given information there. Then step number 1, what am I going to do? I will ask learner to sketch any triangle. I will tell learner to sketch any triangle of your own with the properties described above, and do the following construction. What are those construction? I will tell them that join D to C and E to B. Then draw an altitude H and K relative to AD and AE. Expect them to draw altitude from line AD to E. It means your altitude from AD to E. Then another altitude from AE to D. That is the altitude. I'll ask them to draw that. Then step number 2. I will ask the learner to calculate the ratio of the area of a triangle ADE and triangle BDE. Remember, triangle ADE and triangle BDE, they have same heights, as I have shown in my introduction using the sketch pad, that the triangles have same height. Then I ask them to give me the ratio. I'm expecting them to give me a ratio like this one. The area of triangle ADE is equals to half the base of AD multiplied by height, of which is h, then divided by area of triangle BDE is equal to half base. What is our base there in this triangle? BD multiplied by height. What is our height? h. Then they simplify, we ended up with AD divided by BD, and then in bracket same height, because they share the same height, that's why they have AD divided by BD. Then in step number 3, I will ask the learner to calculate the ratio of the area of a triangle ADE and triangle CED. Okay, from there I'm expecting learners to give me a ratio of the area like this one. Area of a triangle ADE is equals to half. What is the base for that triangle? The base is AE multiplied by height. What is our height now? In this case, our height is K. And now area of a triangle for triangle CED equals to half base, the base there, EC multiplied by our height. What is height? Okay. Then because they have the same height, now we ended up with AE divided by EC for that step 3. Okay, now let us move to step number 4. Step 4, I ask learner to compare the area of triangle BDE and triangle CED as they are between parallel lines, and I ask them to write down their conclusion. As I have shown them that if the two triangles are between the parallel lines, I am expecting them to give the answer like this one. The area of triangle BDE will be equal to the area of a triangle CED, because they have same base and they are between parallel lines, and I have shown that using a sketch pad to convince them. Okay, step number 5 now, our last step. From the step 4, since area of a triangle BDE and triangle CED are equal, and they all divide the area of a triangle ADE in both step 2 and step 3. Then I ask learners to write down a conclusion based on ratios found in step 2 and step 3. As you can see, they all divide what? Area of a triangle ADE, and then step number 2, they divide area of a triangle ADE with triangle CED. As I have shown in step number 4, that triangle BDE and triangle CED, they have the same area. It means now I can conclude that area of a triangle ADE divided by area of a triangle BDE from step 2 is equal to the area of a triangle ADE divided by area of a triangle CED from step 3. Then now we'll simplify, substitute those areas and simplify. We ended up with something like this. AD divided by BD equals to AE divided by EC. As you can see there in my given information, what I was required to prove, I was required to prove that AD divided by BD is equal to AE divided by EC. Now in step number 5 is my final answer. I got that AD divided by BD is equals to AE divided by EC. Now, wow, I can conclude that if we're given that from that given information, I can conclude that I conclude that if we have two triangles and there is line drawn parallel to each other, then the side in those triangles are having proportion, showing that AD divided by BD equals to what? AE divided by what? To EC. And I have shown that, I have proven that theorem as I have required to prove. Then in my, this is what you was all about my development. Then in my conclusion now, let us move on to my conclusion during this lesson. In my conclusion, I will then sum up the lesson with formal proof as follows. This is my formal proof. I'll summarize my lesson, giving the learners my formal proof as it is, all the given information, what are required to prove, all the construction and proof as a whole, so that they all able to write this proof formally. Then now, in my assessment, when I'm going to assess my learners during this lesson, on my assessment now, I will, since learners will be introduced to new theorem in class, they have to be given time to digest. Therefore, I will then give them an exercise with a simple application of the theorem, so that they can be encouraged to learn more in this theorem. That here are the exercises. I will give them the simple exercises, simple application of the theorem, that like filling up the gaps there from the understanding of the theorem. These are the simple examples that I will give them. Example number 1, example number 2, and example number 3, example number 4, to write their answers based on what they have learned so far about that theorem. And remember, our objective number 2, they say the learners should be able to apply this theorem. Now they have to apply this theorem because now they know that if we have a triangle and we have a line divide that triangle, it means sides divide the sides are in proportion, so they have to apply that theorem. Then this is another problem that you can do. Problem number 5, problem number 6, problem number 7, and problem number 8 is a simple application of the theorem. Okay, this is all about my conclusion based on this lesson. Then that will be the end of my lesson, and thank you for your attention. Here are my details, email address there, and my cell phone number. My name is Melulek Shabalala from Ukzn, and this is how all about my lesson. Okay, the advice for teachers. Okay, what is the most important thing for us, for teachers, is to bring a lot of resources in class. As we all know that as a teacher, the most important thing for teacher is to convince learners. That is the only purpose for us teachers, is to go there in class and convince learners. And how are we going to convince learners? Is to use different resources to convince learners. It means we have to bring a lot of resources in class to convince learners. And a textbook, it is not if when you use only textbook for as your resource, it is not enough to convince learners. We have to bring another resources so that you can convince the learners, and you can use practical example as much as you can, so that you can convince learners, and so that they can get even the understanding. And if you can reflect from high school, from a good mathematics teacher. A good mathematics teacher is the teacher who is able to use practical example to teach, used to bring resources in class, used to use practical example in teaching, so that you can able to understand the concept better. As much as you bring the resources, as much as you bring resources to convince learners, it is make it so easy for learners to grasp the concept, to understand the concept. So make sure that you use the resources as much as you can. And technology is the most useful resource to convince the learner. So try and make sure that you use technology as much as you can, so that you convince learners. They get excited about technology and they want to learn every time, so that they can get the understanding of the mathematical concept. So make sure that you use the resources, and thank you very much for your attention. And please feel free to make comments. Here is my number, 0733 18802, and Shabalala Melulegi from Ukzn Edgewood Campus, and how I teach it lesson. Okay, thank you so much. And for Mathematics Department at Ukzn and the leadership of Sarah Pansiran for giving us the opportunity to share our ideas, and I'm proud that I'm from Ukzn and I will be the teacher that is most required in the environment, and I want to make change in high school so that they can understand mathematics better. And thank you very much.